Okay, so we didn't get very far in section 1.5 yet. We were covering quadratic equations. And we started off talking about the zero factor theorem, also known as the zero product rule, right? So let's let A and B be two algebraic expressions. It can be anything you want. If A times B is equal to zero, then A equals zero or B equals zero. One of those things has to be true at least, right? So how can we use that? Well, suppose we had a product of two linear factors like this. X minus 5 times x minus 2 equals 0. Okay, well, by the zero product rule, that means that either x minus 5 has to be equal to 0 or x minus 2 has to be equal to 0. And so we'll solve each linear equation, right, because we know how to do that from section 1.2. So x minus 5 equals 0. We know we had to add 5 to both sides of the equation. When we do that, we get x on the left-hand side, we get 5 on the right-hand side. So x is equal to 5. X minus 2 equals 0. If we add 2 to both sides of the equation, we get x equals 2. So then we have two solutions, 2 and 5. Okay. And that's how we use the zero product rule. Okay. So let's say a quadratic equation is an equation that can be written in this general form. Ax squared plus bx plus c, where a, b, and c are some real numbers with a not equal to 0. And anytime in a definition it tells you that, oh, this constant can't be equal to something, you should probably ask why. Right? So if a were equal to 0, then ax squared plus bx plus c would be the same thing as 0x squared plus bx plus c, right? But 0x squared is just 0, so that's gone. So that's just the same thing as saying bx plus c is equal to 0, which makes this a linear equation, not a quadratic equation. And so that's why a is not equal to 0. Okay? So we're going to talk about solving quadratic equations, right? So here's a general strategy for what we can do. If necessary, we would rewrite the equation in general form. So remember that a quadratic equation can always be put in this form. It might not be given to you in that form, so it might require a little bit of algebra, right? Move everything on the one side of the equation, right? Okay, step 2, factor it completely. That's, of course, where the hardest part of this is. Then, after it's already factored, now you apply the zero product rule, and then you solve the equation in step 3. So let's look at a special case of this. Suppose that c is equal to 0, right? So you have ax squared plus bx plus, well, your c is 0. So you just have ax squared plus bx, right, is equal to 0. So for example, we have 4x squared minus 2x is equal to 0 here. There's no constant term, right? And so the trick to this one is to factor out the greatest common factor. But you forgot how to do that, right? Well, we have two terms. We have 4x squared and we have 2x. You can ignore the minus sign out front. It doesn't matter in the greatest common factor. So 4 is the same thing as 2 squared. So really this is just 2 squared times x squared. And then 2x here is 2 to the first power times x to the first power. Now the greatest common factor is you gather up all the different factors that you have here, which are 2 and x, and you raise them to the smallest exponent on each one. So this is 2 to the first power times x to the first power. So the greatest common factor is 2x. Okay. So if we look at 4x squared minus 2x equals 0, we want to pull out the greatest common factor here. We want to write this as 2x times whatever is remaining. So we need to make sure that 2x times this thing is equal to 4x squared, right? So since we pulled a 2 out of the 4, we should have 2 left over. Since we pulled a copy of x out, we should still have 1 copy of x left. And then now we can just check it. 2x times 2x is 4x squared, right? Okay. Do the same thing with this term, but of course we're pulling out 2 and x this time, so we should just be left with a 1 over here. So we have 2x minus 1. Okay. So now this thing's completely factored. 2x times 2x minus 1 is equal to 0. Apply your zero product rule, and that tells you that either 2x is equal to 0, which we can solve to get x equals 0, or 2x minus 1 is equal to 0, which we can solve to get x equals 1/2. So 0, 1/2 is our solution set. Okay. We did an active engagement assignment where we had 3x squared plus 27x is equal to 0. We pulled out the greatest common factor, which was 3x. And I crossed this out because you don't need to show me that work, right? If you can find the greatest common factor, great. So I'm going to pull a 3x out of both these terms, right? 3x out of here, we'll just have 1 copy of x left over, right? 3x out of here, well, 27 over 3 will be 9. And then we've pulled the x out already, so we just have 9. Okay. Now we apply the zero product rule, and we get either 3x is equal to 0 or x plus 9 is equal to 0. We solve this one, we get x equals 0. We solve this one, we get x equals -9. So then we get 0, -9 as our solution set. Okay. Now, depending on the author of the problems in MyLab Math, they may tell you to put it in increasing order, right? In which case, -9 is smaller than 0, so the -9 would come first. But again, that depends on the author of the problem.